Okay, in the previous tutorial we have finished the Hello World tutorial of RabbitMQ and we saw the communication. Now we are gonna move to the second tutorial. We were gonna do only 3 tutorials. Time to move to part 2 and build a simple work queue. Now, how else can we use RabbitMQ? Actually, we can use it as a uh, broker for a work. It came to my mind that George, that's your role. You broke a different. You actually sent a different tasks to different workers, and they get the job done. Do you understand? This is the idea here.
Yeah, that's how it's work in the real world.
Yeah. Welcome to the real world. Actually, the producer pushes the different works and sends them to the workers, clients, consumers, which are um, obligated to get the job done. So this is how can you something very how to say that something which is very intense calculating intense task can be broken on many different tasks and sent to many different workers. So this is again the answer to such a problem. In this tutorial, assume RabbitMQ is installed. I already showed in the previous tutorial how this is installed. Actually, I'm running this using the docker run it blah blah as a Docker container. Here I'm keeping this PowerShell just to show the Docker PS. So right now RabbitMQ is running as a Docker container on my machine. So now let's do this. In the first tutorial, we wrote a program to send and receive messages from a named queue. In this one, we will create a work queue that will be used to distribute time-consuming tasks among multiple workers. For example, you have to render a very complicated scene, for example, from Avatar. You can split this work on many chunks and send it to different workers to get it done. The main idea behind work queues, aka task queues, is to avoid doing a resource-intensive tasks immediately and having to wait for it to complete. It's a singular task, sorry about that. Instead, we schedule the task to be done later. We encapsulate the task as a message and send it to the queue. A worker process running in the background will pop the task and eventually execute the job. When you run many workers, the task will be shared between them. The concept is especially useful in web applications where it's impossible to handle a complex task during a short HTTP request window. Preparation. In the previous part on this tutorial, we sent a message containing "Hello World." Now we will be sending string that stands for complex tasks. We don't have a real work task, like images to be resized or PDF files to be rendered, so let's fake it by just pretending we're busy by using the thread sleep. Thread sleep just stops the current thread for a certain amount of time. You determine that. Function. You'll need to add using system threading near the top of the file to get access to the threading API. We will take the number of dots in the string as a complexity. Every dot will account for 1 second of work. So in other words, we will sleep 1 second every time when we meet a dot into the message which we have received from the producer. For example, a fake task described by hello, 3 dots, 3 seconds sleep. Will take 3 seconds, which is gonna imitate, is gonna fake actually that worker is busy right now doing something. Actually, he is gonna sleep 3 seconds. We'll slightly modify the send program from our previous example to allow arbitrary messages to be sent from the command line. This program will schedule tasks to our work queue. So let's name it new task. Okay, so I have to do some preparations here. First of all, I'm gonna close my Visual Studio Code because I have the previous tutorial. Shall I close it? No, I'm not gonna close it because they said that they're gonna use the code from our previous example. So what I'm gonna do right now, gonna create another folder because I again will have two different console applications. One of them is gonna be a new task, another one is gonna be a worker. So let me do make directory rabbit, not message, yeah, RabbitMQ, but it's gonna be called how shall we call this? Actually, work queues. Okay, so this is how I'm gonna call this project, work queues. I'm gonna switch to this folder. Now I'm ready. Let me see if they have instructions for, oh, here you go, they again have it. So this is what I'm gonna do now. .NET new console minus minus name new task. I'm creating this console application. Okay, restore succeed. um uh, Let me start the code here, Visual Studio Code, so we'll see what's going on. I'm gonna close this, George, for now. Can you still hear me? Yes.
Yeah, yeah, I can hear you.
Perfect. Azure repos. Okay, I opened another instance of the Visual Studio Code, and here we go. We have a new task. Yes, of course I want. Now our program is called program CS. As you can guess, now we are going to rename it. New task. Okay. Whatever is in new task folder called program CS, rename it to new task folder, new task CS. Okay, it's going to be renamed right now. Let me go back here and just make sure that happens. Here we go. We see it. So we have only one folder so far. Soon we will have a second folder which is called worker, probably. Yep, here we go. .NET console worker. And we can have 3, 4, 5, or as many as we want workers. And we can distribute many tasks for them. .NET console worker. Okay, we have created the worker. Now let's rename the program in the worker. Let me see it in the Visual Studio, not this one, this one. Here we go, the folder worker with the program inside. Okay, I'm gonna close this right now and run the rename command. Now it has been renamed. Come on, worker, worker. Okay. And now what else do we need to do? Now install the packages. Change directory, new task. So this is the broker which distributes the work, the job across the different workers. We are gonna go to new task and install the package. Otherwise we won't be able to use the Rabbit message queue, or we have to write it ourselves. We have to know how to open socket, how to communicate with Rabbit server. But this job is already done, so we don't have to do it again. RabbitMQ client. This actually changes here the, you know what it is. It's a worker. I did it in the new task, so we can see it here in the new task. Is a share project. Look at this package reference, which is a NuGet package. Okay, has been installed, and let's continue. .NET Restore actually is gonna download. This is what it does. It's gonna download this package. Determine projects to restore. Restore the project, blah 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 blah. Just for any case, I don't think this is absolutely necessary. We're gonna switch right now to the worker and do the same. Install the very same package for our second application, which plays the role of the worker. Let me do it one by one though. .NET worker package, rabbit client, blah blah. And now we are gonna run again .NET Restore. .NET Restore, and we are almost done. Okay, now Look, they actually don't give you the code. They say basic publish exchange. They just mention the code snippets, but they don't show us the code yet. So we are gonna use the code which we have already from our previous application. Let's copy the code from Hello World and just compare. This is a uh, good example. Okay, from send, what we have to do now? Very simple. We have to instantiate a factory, say where actually the message queue is located, open a connection, open a channel. Let me copy this and put it in our new task here. Okay, so again, I'm gonna just comment this one. Close this again, save it. So we have a using statements, nested, connection factory. Look at this, is gonna come from the namespace use it, RabbitMQ client. Okay, so we just added this namespace. Now we are ready with the channel, and we actually can copy the code. Var message get message argument, so all this stays the same, they say, from the sender. Are they talking about the sender? Like Taurus, we need to generate two projects, okay? Actually, this remains the same, I believe. So let me see. Uh, this is the same though. So we use the channel to create a queue which is called hello, durable false, exclusive false, auto delete false, arguments. We are not gonna go that deep into the rabbit hole. So whatever it's necessary just to run it, it's okay for us. We are not gonna discuss these parameters. Those are formal parameters to the constructor, to this method actually. Okay, message channel, blah 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 blah, send message. Let me copy all this. We will need this probably, so I hope that we are gonna need it. Gonna copy this again. Rabbit message queue. That's a new task. Encoding. This comes from system text. System text. Okay, so now, what else do we need here? Console, press enter, and I did it this here before we close the connection. Okay, so that's it. Now let's read further. See what they say here. Var message get message arguments. So this is the receiving part. Do you know? This I get is the receiving part. So I'm gonna do the receiving part first. This is not the sender. They explain first the receiving part. String message, console. Okay, I need the new task, but let's go to the receiving part, worker. So the worker will need the very same things. Two using statements nested in each other for opening the channel, console write line, okay. And this one, worker. I'm not trying blindly to follow the tutorial. I'm trying to put thought on that. Do you follow?
Yeah, follow.
Okay, so we open the connection, we open the channel. Now the creating the query is idempotent, so I don't care. It should be created either from the worker or from the server, from the producer. It doesn't matter. Somebody
Why
needs
we're
to.
not using their properties? Like,
Pardon me?
why we're not using their channel declare from
Uh,
the tutorial?
we're using their.
Because they
Listen, they don't even mention the channel. They just start immediately. after the channel, after the queue, actually, it's already created, and they just discuss what do we need to get the message
Okay.
from the receiver. So as you can see, the tutorial is not complete here. They don't give you the all steps. They just give you the code snippets which needs to be changed.
Yeah.
So that's why I'm copying and pasting, going back and forth, which is a good brain gymnastics, actually. I like that. So this is what they do here. Uh, Look in the receiving part from the previous example. In the receiving part, we have created the queue, which we already discussed that it's idempotent. Here, I did the same. Here, these lines of code are not questionable, right?
Yeah, yeah, they're same.
That's absolutely clear. This also is absolutely clear, and it's the same, like on the receiving part. And these lines of code we have on both, on the sender and the receiver as well, simply because we need a queue, and somebody needs to create a queue, and it's not clear which one is gonna start first. So either the worker or either the sender actually should create the queue. The queue should be there, should exist, right?
Yeah.
So after that, when we receive the message, get message, this get message doesn't exist, and I don't know why it's not in red right now. But I copy this part from their tutorial, which talks about the task queue here. Look, task queue, task queue. We'll see. It's a little bit strange that the queue is still called hello, but routing key is task queue. If it's necessary, we will change this. We'll see that later if we have any issues. So var message get message arguments. This is a method which they call, and we have to define this method. Unfortunately, here they don't show that, but I'm gonna do it. I don't know why. Right now, it's not uh, showing that this guest message is not existing. I have to declare this method arguments. Arguments are coming from the command line. They're gonna use the arguments when you run your .NET. We are gonna send arguments. So those are the arguments which they're gonna use, and those is gonna be hello dot 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 5 times dot. So the worker is gonna work different time. Only this is the difference. Var body encode, here we have the very same thing. Let me compare actually with what we had here. I hope it's not too confusing. Is it confusing actually?
No, it's pretty clear at the minute, but yeah,
Look,
some stuff.
before when the message gets received, actually what's gonna happen is they call this callback, which just prints the message on the console. That's it. And the rest is the same. So this is actually uh, the useful work which our receiver is doing. In this case, in the first example, hello world, the callback just prints something on the console. In this case, and the message here is absolutely clear. Let me see where the message is. Yeah, here we go. Just prints the message. But in this case, let me declare this method, which they have here in the, so it's clear what it does. Here we go. Private, static, because it's a console application, of course, and the main is calling it. Main is static, so that's why this also is static. So here we go, what we do. Arguments, worker, private, static, argument length, string join argument, hello world. Mm, get message. I'm still confused a little bit. Is this the sender? I think this is the sender. Channel create basic property. Persistent true. Channel basic publish. Change task queue. What do you
No,
think?
probably because I see the method. Yeah, if the length is bigger than zero, then you string join, and then you send hello world, or but oh
No,
yeah,
but you
that
send
that's
it.
the
This is the
sender part.
sender. This is the
Yeah.
sender. This definitely is the sender. So let me go back. Let me go back and put all this code in the sender. This is after the main. Okay. And here we're gonna change the worker. But as we can see, there are not that many differences. I think this is the sender. I'm gonna copy this, cut it, and put it here. Somewhere down the line, probably they will show the entire code in one file, but I'm not quite sure. So, and this console press enter could stay here because as soon as I send the message, this process will continue running, and when I hit a button, actually it's gonna close. It doesn't matter that the sender is still alive and it's still a process. I don't care about that. The most important is just to send. And what it happens is, yeah, get message. This get message, actually what it does, it gets the message from the arguments. That's it. And if nothing actually is sent as an argument to the running program, it just sends a hello world. Otherwise, string joined, all the arguments are joined together with a space between them. That's it. This is what it does. Yeah, this is the sender. This definitely is the sender. So, worker, this was the sender. Sorry about this going back and forth, but hopefully now it's clear. Task queue. They didn't even mention that into the tutorial. They're not talking about is this a sender in the beginning. We need to generate two projects. Okay, they didn't discuss this code, but we figure out what it is. And now, on our old receiver CS script also requires some changes. Now they start talking about the receiver. So this definitely was for the sender, right?
Yeah, I think it was for the
Yeah,
sender as
this
well.
is
Yeah.
what I think. This is what I think, and I think we are right in this case. Let me run it in full screen. Okay, so new task. This is how we determine the task. We receive something from the console, and after that we create the message. Here we go, the message. We encode the message with UTF-8. Properties, channel create basic properties. Properties persistent true. In other words, of this channel should be saved at the same time on the hard drive. So eventually, if the message queue server crashes, the next time you start it, actually it's gonna know that there is work which is not done, and it's gonna send the work again to the workers. This is the message. This is actually the reason for this. Okay, let me read it carefully and we'll figure this out. Now, on alt receive CS script also requires some changes. Okay, that's clear that the code, the previous code, this was for the sender. Now they're talking about the receiver. It needs to fake a second of work for every dot in the message body. Okay, so this is our worker right now. It's clear that it needs to create a queue. Now I'm gonna switch back to our Hello World project where we have the receiver, and let's think about receiver now. So we have this code. The alt was this one. This is the worker. So what it does is actually runs permanently, but let me go here. Var consumer, new event. This is the event handler. Now channel, and let's compare with what we have to do now. Okay, so this is the old code in the worker. Let me compare now with what we have, what we should have. Var consumer entity basic consumer channel. We have that. Here we go. Var consumer and eventing basic consumer channel. Okay, you're gonna receive the event from the channel. Okay, now consumer receive. Here we go. Our callback. Now the callback is gonna change. Consumer receiver. Before it just was printing on the console the mm, the message. Now var body EA var body EA event action probably is this abbreviation. Var message encoding, so far so good. We have the very same thing. Var message encoding ETF awesome, UTF-8, and instead of just printing on the console right now, we still print it, but now we have more code. What happened? Yeah, it was selected, and when I hit enter, actually get deleted. Now we have in dot message split. Now it counts the number of dots sent by the uh, basic consume. Okay, so let me do that. Now in dots counts the number of dots, sleeps for each dot actually is gonna sleep 1 second, 1000 of milliseconds, which is 1 second. Console write line done when the job is done. Channel basic queue, and after that it does channel basic consume queue task queue outlook acknowledgement through consumer. Okay, this is what it does. Instead of this, look now, channel basic consumer, here it's on 4 lines, here on 3 lines. They did it in 1 line here. I
They
believe it.
just change the they just change the message task queue instead of hello, and that's all. They
That's
use
all.
it just.
Yeah, uh, and they changed the queue. Look at the queue. The queue right now is task queue. I think there is an error into this tutorial. Look, I don't know, but I'm pretty sure that there is a. This is not gonna work because our queue is called. Look,
Hello.
hello. I, I'm.
Yeah, we can easy change
Yeah,
like
we
task
will
queue
change. We will
or
try
queue name.
this.
That's a queue name, isn't it?
It's a
So
queue
yeah,
name exactly.
it's gonna be error because our queue name is different. It's
Yeah,
hello.
our queue name. So I'm gonna comment this just for a second. But I'm pretty sure that right now we are gonna get the error message, or at least this is not gonna work. I'm gonna follow the tutorial anyway, but let's see. I think that there is something wrong because the queue we are creating is hello, but the channel basic consume queue task queue auto acknowledge consumer, or maybe we are wrong. But common logic tells me that there is something wrong, and this cannot be like that. And here they explain what they do. Actually, these 3 extra lines after printing on the console that message has been received, they fake that they're working. In fact, the process is sleeping for as many dots as we have in seconds. Okay, so sleep dots, round robin dispatch. Okay, let's read about that. Let's try to figure out what's going on. We have the code written already. We can try running it. I'm pretty sure that look, hello is the name of the queue, but routing key is task queue, right? So there is definitely something wrong with this. Um, round robin. Let's read about this round robin and try to run it as it is. Okay. I'm gonna keep this. Okay. So round robin dispatching. One of the advantages of using a task queue is the ability to easily parallelize work, to make it parallel. If we are building up a backlog of work, we can just add more workers, and that way scale easily. That's very good. Yeah, that's true. First, let's try to run 2 worker instances. So we are gonna run 2 worker instances. They will both get messages from the queue, but how exactly? Let's see. You need 3 console open. Okay, I have already 3 console open. I have more than 3, but let's say in these 2 which are next to each other, I'm gonna run the workers. So let me switch to the folder with the workers, and let's put them together like that. And after that, I have another console prepared in which I'm gonna run the producer of the work. Okay, so let me switch here. change directory, back, change directory, rabbit. But this one, worker. Okay, so let me change to worker. Okay, I'm in the worker right now. This is the first worker. Now I'm gonna switch to the second worker. Again, worker. Okay, I have two workers. Let me change to here in this console. Let me go to our trash folder. I shouldn't be calling it trash. I should rename it to something more meaningful. This is not a trash art, definitely. I have a hard time calling whatever we have done a trash, so probably. Okay, but I'm gonna do this later. And this is new task, as far as I remember. So we are ready. We are ready to go. Rock and roll. We'll see. Maybe we'll get errors. We already saw that there is something smelly into the code of this tutorial, but we are not afraid, of course. We're
Also, I want to mention here we have to add our message to be hello with three dots because at the minute
here we go.
we don't have the dots.
This is on the new task.
Alright, yeah.
Yeah,
Okay.
so the workers, they don't need
So
anything.
we're not gonna hard code our message. It's gonna be just we give the message from the console.
Yeah, exactly, exactly.
Yeah.
So we're in the workers right now. Let me switch to the workers, and I'm just gonna run them. And as I said, I suspect that there is something fishy, something smelly. At least in the best case scenario, probably we're just not gonna receive the messages, because the queue is called Hello World, but we are listening on the queue which is called task queue, and task queue I don't think exists. So let me try that. So .NET .NET run. Okay, so let me wait until, yeah, error. So what is that now? Worker CS error, blah blah. The type or namespace connection factory could not be found. Why didn't get why didn't I get message that connection factory, the namespace is missing? That's a real. See, I had this problem with my Visual Studio Code, and it disappeared after update, and now I have the very same problem. Yeah, that's very frustrating. Before, when I was using my Visual Studio Code, I didn't have such problem. It showed me that, for example, I don't have this method. You know how it is. It shows a curly line beneath the get message just to show me that this get message is missing. And when I hit the control dot, it gave me suggestions. As a proof, I can point our first tutorial where it was working. And actually this one, when I started to work, I didn't have problem, but now there is a strange bug. Okay, anyway, so we have enough bugs to deal with. Right now, let me try to run it. We suspect anyway. Again, worker CS error, the type namespace eventing basic consumer. Yeah. Um, I'm trying to run the worker, so let me switch to, here we go, client event. I just copied the namespaces from our receiver, and because the code is absolutely the same, almost the same, except this lines of code here and this line of code, so that's why I'm pretty sure that should be working now, right? You you can help me? Worker. The
Yeah, it's
name thread does not exist in the current context. Yeah, of course. System threading.
yeah.
Come on. Using that's awful. System threading. At least the IntelliSense works. Oh my god.
At least something works.
At least something worked. Yeah. Okay, so now another exception. Unhandled exception, rabbit message queue, but this is better. It's not syntax. RabbitMQ client exception operation interrupted exception. The advanced message queue protocol operation was interrupted. Close reason initiated by peer code 404.
Yeah,
Text
your
not
suggestion,
found.
no queue, task queue. That's the way.
Task
Yeah,
queue. No
we
queue
just have to
task queue
change the
in
name.
vhost
Yeah,
plus blah 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 blah. Okay, so what we suspected, right?
yeah.
Channel
Your
basic consumer.
your personal intelligence.
My personal intelligence, yeah. Wait a second, let me go back to our. By the way, do you know I'm gonna close this hello world because we don't need it anymore. We exploit at maximum. We copy everything, right?
Yep.
So I'm not get confused. Um, because I was about to make changes there. Now, task queue, it's clear. Okay. So instead of hello, here I'm gonna do task queue. Is this all? I think it is okay now. Now, in the new task, we are gonna get problems if we don't use task queue and round key task queue. Okay, so I guess we are ready to go now. We should be ready to rock and roll now. Okay, let's try. .NET run. Now press enter to exit. Now we have one worker running in one of the terminal window. Now another one. So .NET run. We have two workers now. This is the second worker. The very same programs, but as you can see, they are different processes for the operating system. Each one of them is running in a different window, in a different PowerShell, okay, different terminal, and both of them are waiting for messages from our new task. They're waiting for tasks to be assigned. Okay, so change directory, new task. I did already this. .NET run first message. Okay, I'm gonna minimize that. So let's look at our first and our second worker, right? Let's see what happens now. I'm gonna call it this way. Now we have only one dot. So whoever of the workers is gonna execute this is gonna wait 1 second. Let me see now what happens.
Yeah.
Receive first message. Do you see that?
Yep.
And it has been sent from here with only one dot, so 1 second. Notice this worker executed the first task. This is crucial. Look how the dispatcher actually dispatches the work with round robin. So it sends the message to one of them. Now it's gonna send the message to the second one. Look, .NET run message 2. Look now, this one is gonna uh, this one get the message assigned to it this time.
It's like load balancer.
Um, yeah, but it doesn't actually cares about who is more loaded. It just spreading the work. Sends the first message to the first, second to the second. It doesn't matter who is ready to work, actually. It's a little bit unfair. It's unfair. Now, every every odd message, so the first one, the third one, the fifth one, is going to be sent to this one. And every even is going to be sent to the second. Look. Now, look, message with 3 dots. This one is going to receive it. Receive third message. First and third message are received by our first client. So this is round robin. This is a good example. It's a fundamental. This means round robin. Our sender doesn't care how loaded they are. It's just spreading the messages between one and the second one. Okay. So now this one is going to execute it. Receive fourth message. And the fifth message is going to go again to the first worker. But at least we have workers. We can have 10,000 workers if we want. We can divide the work and send it to different workers. And here we go. The first, the third, and the fifth message have been received and executed, and now it's done. by the first worker. The second one received the second and the fourth message. Okay, so let's see what is delivered to our workers. Shell 1, waiting for message, exit, control, blah blah. First message, third message, fifth message. We already noticed this. By default, RabbitMQ will send each message to the next consumer in sequence. On average, every consumer will get the same number of messages. This way of distribution messages is called round robin. Try this out with 3 or more workers. So it's gonna send to the first, to the second, to the third. If you want, I can run another console and run it again. Do you think it's necessary? I think that's okay.
No, we got the
Got the
conception.
idea. Yeah.
Yep.
So even if you have 10 workers, actually the distributor is gonna send the message to the first, the second message to the second, the third message to the third, and after that is gonna repeat. So doing a task, messaging acknowledgement. This is this is a problem which we are going to talk about right now. This is a little bit longer tutorial, but I think we will survive through this. So doing a task can take a few seconds. You may wonder what happens if one of the consumers starts a long task and dies with it only partly done. With our current code, once RabbitMQ delivers a message to the consumer, it immediately marks it for deletion. Let me go there and see auto delete false. How that's possible? We said auto delete false, but
I think that deletion is coming uh,
from the channel?
from no from acknowledgement
Yeah,
argument
yeah.
in the worker, not in the
Then
like auto acknowledgement.
Yeah, yeah, yeah. Here we go. We'll try that. We
Yeah.
will see. We will see now. Okay, so with our current code, blah blah blah, to the consumer immediately marks it for deletion. In this case, if you kill a worker, we will lose the message. It was just processing. We will also lose all the messages that were dispatched to this particular worker, but we are not yet handled. But we don't want to lose any tasks. If a worker dies, we would like the task to be delivered to another worker. That's okay. In order to make sure a message is never lost, RabbitMQ supports message acknowledgements. An acknowledgement is sent back by the consumer to tell RabbitMQ that the particular message has been received, processed, and the RabbitMQ is free to delete it. When the worker finishes the job, he sends the acknowledgement that the job is done, so it then gets deleted. If a consumer dies, we'll see how that is done. If a consumer dies, its channel is closed, connection is closed, or TCP connection is lost. Without sending an acknowledge, RabbitMQ will understand that the message wasn't processed fully and will re-queue it. If there are other consumers online at the same time, it will then quickly redeliver it to another consumer. That way, you can be sure that no message is lost, even if the worker occasionally die. Perfect. Just let me take a look. I have to stop and I will continue recording just in a second. Okay. If a consumer dies, we already read that. Without sending acknowledgement, it can okay, so on and so forth. Let's see how we can send the acknowledgement that the job is done, which means for the rabbit message queue that he can delete the work from the queue. There aren't any message timeouts, so timeout cannot be used to remove the message. RabbitMQ will redeliver the message when the consumer dies. It's fine even if processing a message takes a very, very long time. So RabbitMQ is not gonna delete it, the message. Manual messaging acknowledgement are turned on by default. Okay, so we have to delete. We have to actually acknowledge that the message has been done. Let me see it. Here we go. Look at this. Auto acknowledgement true. So this is false by default. This is false by default, as I understand it. Correct me if I'm wrong, but I think this is exactly how it is.
It's true. It's turned on by default. That means it's true by default. In my
Uh, but this is the manual. Uh,
yeah.
this option is automatic. So
Yeah, yeah, it's
automatic acknowledge true, which means even if I'm not finished, acknowledge that I'm done, which means I don't care if the work is done or not too much. So I send it to true, which means automatically reply that you have done it.
okay.
So if we set it to false, I believe, we will see that further. If we set it to false, that means that I am responsible to send at a given moment that I have done the job. In previous examples, we explicitly turned them off by setting the auto acknowledgement, automatic acknowledgement known parameter to true. Here we go. Yeah, exactly. So it's time to remove this flag and manually send a proper acknowledgement from the worker once we are done with the task. Okay, where is that? Here we go. Only this. And what is that now? Note, it's possible to access the channel via the event blah 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 blah. What is that? So this should be in the worker, I believe. This should be somewhere in the worker. And what does it say? Console write line done, X done, okay. And before they finish, they have put here something. What is that? Channel basic acknowledgement delivery tag. Look, in C# we can actually mention the name of the formal parameters and send values in a different order, multiple false. Note, it's possible to access the channel via channel basic acknowledgement. Here we go. Here we go. This is how we acknowledge that the job is done. After we report on the console that the job is done, we send to the channel basic acknowledgement delivery tag blah blah delivery tag multiple false. So this is how we manually
This is our feedback.
acknowledgement. Yeah, this is our feedback that we have done the job. It's done. It's completed. And it is inside of the callback. So when the callback is done, so this should be probably the last line into the callback. So it's not absolutely true, of course. It could be somewhere else if there are conditional logic, but whatever. So this is how we manually acknowledge that it's done, and this we are gonna turn to false. Here we go. And channel basic consume blah 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 false. So we are not gonna see any change, in fact, any changes in the behavior, but the acknowledgement now is done manually. I'm gonna comment this just to remind me that manual acknowledgement. Manual acknowledgement, okay? So this is the acknowledgement. These two lines of code, we discovered them. Using this code, we can be sure that even if you kill a worker using Control C while it was processing a message, nothing will be lost. Soon after the worker dies, all acknowledged messages will be redelivered. So if I leave only one worker, in other words, um, this worker will receive the work. Acknowledgement must be sent on the same channel that received the delivery. Attempts to acknowledge using a different channel will result in a channel level protocol exception. See blah blah blah. Forgotten acknowledgement. It's a common mistake to miss the basic acknowledgement. So it's a common mistake to forget to acknowledge that you have done the job. It's an easy error, but the consequences are serious. Messages will be redelivered when your client quits, which may look like a random redelivery, but RabbitMQ will eat more and more memory as it won't be able to release any acknowledged message. In order to debug this kind of mistake, you can rabbit blah 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 blah. Okay, so let me actually try to log into our Rabbit Docker to run these commands just for fun. Docker ps, okay, it's running. Now I'm gonna say docker exec minus interactive exec RabbitMQ bin bash just to log in. Okay, so I'm into the machine, and now I can say rabbit list QLE because I'm sudo anyway, so I'm gonna miss this. Okay, so this is how we communicate with Rabbit inside of the Docker container. Listing queue for vhost name. Hello, it task queue. Here we go. Those are the queues. Message ready 0, message acknowledged, unacknowledged, message 0, unacknowledged message. Okay, Rabbit, but list on the Windows. We are not in the Windows. Are you still with me?
Yeah, yeah, I'm here.
Okay, sorry about that. Message durability. Mm, we have learned how to make sure that even if the consumer dies, the task isn't lost, but our tasks will still be lost if RabbitMQ stops. Okay, what if the server dies? When RabbitMQ quits or crashes, it will forget the queues and messages unless you tell it not to. Two things are required to make sure that the messages aren't lost. We need to mark both the queue and the messages as durable. Okay, so we need two things to do. The queue and the messages are durable. Um, Durable. Okay, let's go to the code and see where that is. When we run it, we say here false. Now we have to say true. And where is the message? I don't see the message. Okay, so first we need to make sure that the queue will survive. A rabbit message queue node restart. In order to do so, we need to declare it's a durable. So durable true. And I'm gonna do this in bold. In the client, in the worker, and in the client producer. True. True, false, blah 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 blah. Okay. Worker. No. Yeah, like that. Okay. Durable true. Although this command is correct by itself, it won't work in our present setup. That's because we have already defined a queue called hello. In our case, it's task queue, which is not durable. RabbitMQ doesn't allow you to redefine an existing queue with different parameters and will return an error to any program that tries to do that. So actually the queue is already created and it's not durable. In other words, if I try right now to restart the workers and the task dispatcher, we're gonna get error because the queue is already created and it's not durable. But there is a quick workaround. Let's declare a queue with a different name. For example, task query, and I'm gonna call. So we have to create a new queue. In other words, right? So
I think they just now do what we've done before, and we create our queue,
mm,
task queue,
not
and
sure.
they're doing.
No, I don't think so. I don't think so. So since the beginning, I guess the tutorial was wrong. We created the task queue. We created everything right. But now the task queue actually is not durable. If I try to run it now, we are gonna get errors. Let me try. Let me try. It's nothing prevents us from trying, right? Let's break something. So Control C, Control C, Control C, Control C, Control C. Okay, now I'm gonna try to run first uh, the worker. Not the worker, but the new task. Here we go. Unhandled exception, RabbitMQ client exception queue operation interrupted exception. The advanced message queue protocol operation was interrupted on a close reason. Let me bring it a little bit to the left. Recondition failed. See, we're changing the condition uh, of the queue. So I would suggest that we change the queue to durable. I'm just gonna call it durable. Let me try like that. Mm, durable. I'm gonna change everywhere. So now the queue is gonna be called queue durable.
Are they not like forgotten
No,
when we kill the
yeah,
process?
but the server is still running. So see,
Okay.
the server is
Oh yeah,
alive.
yeah, yeah, yeah,
If I
yeah,
stop
yeah.
the server and run it, then it's gonna work. But
Yeah, makes sense now.
yeah,
Yep.
but I have to stop the server. So the queues exist even though there are no processes which are using them. Oops. So task durable. Now it's gonna work again. Ah, come on. What? mm. Hello world. It's okay. Only these are the places we have to change something. Routing key worker. Okay, channel. Delivery. Okay. So task queue durable. Task queue durable. Okay, now we can start it again and we'll make sure that everything works fine. Okay. So now we send the message, but there are no workers which to receive the message. Let's see what's going on now. Let me start the workers now. Let's see who is gonna get the message. The first one received fifth message. Listen, after 5 seconds, the work is done, and the acknowledgement is sent back. So let me look at again into here with this comment and see. Okay, message unacknowledged. Uh, Let me run the message
Can you
and
stop the workers and run the message so we see if there is an unacknowledged
yeah,
message
very good
in it?
idea. We could stop the workers, but at the same time, if I'm fast enough, I believe with 5 dots, the message is not gonna be acknowledged. So I'm sending 5. I couldn't catch it. It should have one unacknowledged message. On theory, this is what I think. And now, where is the work dispatched to? Who is the one who is gonna get it done? Again, the same guy, this worker. Okay, so uh, all of this command blah 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 blah. This queue declare change needs to be applied to both producer and consumer code. Yeah, we did it already. So we changed the durable to true, and we changed the name of the queue to both. Channel create basic properties. Ah, at this point, we are sure that the task queue won't be lost even if RabbitMQ restarts. Now we need to mark our messages as persistent by setting persistent to true. Okay, I believe this is into the dispatcher. Okay, I'm gonna go to the dispatcher, new task, and properties persist true. Ah, it's set already. Actually, they explain the code now. Properties persistent true. Even though persistent true properties channel create basic properties blah. Okay. Whatever. It's okay right now. It was okay since the beginning, but because durable wasn't set true, that's why the messages were not persisted. Note on message persistence. Marking messages as a persistent doesn't fully guarantee that the message won't be lost. Although it tells RabbitMQ to save the message to the disk, there is still a short time window when RabbitMQ has accepted the message and hasn't saved it yet. Also, RabbitMQ doesn't do file sync to for every message. It may be just saved to cache and not really written to the disk. The persistence guarantees aren't strong, but it's more than enough for our simple task queue. If you need a stronger guarantee, then you can use publisher confirms. We are not gonna go that deep into the rabbit hole, right? So fair dispatch. Now, so far, the dispatch is not fair. You get the job, doesn't matter you're busy at that moment. You might have noticed that the dispatching still doesn't work exactly as we want. For example, in a situation with two workers, when all odd messages are heavy and even messages are light, one worker will be consistently busy and the other one will do hardly any work. Well, RabbitMQ doesn't know anything about that and will still dispatch messages evenly. This happens because RabbitMQ does just dispatches a message when the message enters the queue. It doesn't look at the number of unacknowledged messages for a consumer. It just blindly dispatches every end message to the end consumer. We saw that. Okay. In order to change this behavior, we can use the basic QoS methods with prefetch count equals 1 setting. This tells RabbitMQ not to give more than one message to a worker at a time. Or in other words, don't dispatch a new message to a worker until it has processed and acknowledged the previous one. Instead, it will dispatch it in the next worker that is not still busy. Channel basic QoS false. Here we go. So channel basic QoS, I believe it's in the new task.
Now
Channel,
this is a load balancer.
yeah. This is a load balancer, something like a load balancer, even though this term is used in another context. Load balancer is used more like web server, which, yeah, figures out, yeah, it's a load balancer. You're absolutely right. Property persistent. Let me see where it is, where this code is. Channel basic QoS. Here we go. Channel basic queue prefetch false. So in the worker, I believe, yeah, it's here. After creating the channel. Channel basic queues, prefetch size 0, prefetch count 1, global false. And what did they say? Channel basic 0, 1, false. Exactly. So in this form, actually, they use the names of the formal arguments of the method. This is very typical for C#. Okay, so we guessed our code, and actually we have done it pretty well, I believe. Console waiting for message. What is that? Yeah, that's a worker. Oh, channel basic. This is a worker. I put it wrongly in the dispatcher of the work. It should be in the worker. Strange. Console, right? Okay. So the only difference between their code and our code is this one, which is the last their statement, so no wonder it's different. They write on the console, we are waiting for a message, which we don't have. Okay. We're waiting for a message. After that, var consumer. Okay, now we are creating the object for the callback. This is the callback itself, and I think we did it correctly. Yeah, we did it correctly. I don't see any differences. This is the acknowledgement, and even this is correct. So we did it correctly. We created correctly. Durable acknowledgement files false. Consumer. Yeah, I also can cut it this way. so we can see it better. Consumer false, Q task durable. Okay, so I think this is about this tutorial. Now run the task publish publisher. Its final code is this is the publisher. Let me compare just the code of the publisher, even though I'm sure that we are pretty much the same. Okay, so we create the channel, the message, the encoding, create the channel, the message, the encoding, properties, persistent true. We sell that the persistence is true, durable true as well, channel basic publish blah 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 blah, message, channel. Okay, let me see here, console write line, only one console write line, this is what we're missing, and the rest is correct. So when we receive the message, we will print it on the console. This is the only difference which we have between us and the tutorial code. And of course, little things. And here we go. That's it. Okay, so we can run it again just to make sure that everything works correctly. And this is gonna conclude this tutorial. I'm gonna stop it now with Control C, Control C. This one, Control C as well. Any key. Gonna run first the workers. Okay. Waiting for message. And with 5 dots, let's see who is gonna receive it. Okay, again. Who is gonna receive it? The next one. Ah. Yeah, the next one got the message now. If I send more than one message, let's see who is gonna receive it. This is quite a complicated task. Again. Okay, so
You should probably be faster than 5 seconds because
yeah,
it sent it
but
5 seconds.
yeah, unfortunately, it takes time to send it. Anyway, it works, and we got the idea. This is the most important. We are not going to rely on this code. Using message acknowledgement and basic queues, you can set up a work queue. The durability option let the task survive even the RabbitMQ is restarted. We're not going to do that. For more information, I model blah blah blah. Now we can move to tutorial number 3. Okay, this concludes our tutorial, and we were gonna create a third one.